I am designed to provide information and assistance on a wide range of topics. However, I cannot directly help with finding employment. Hurricane season is a period of heightened weather activity, particularly in coastal regions. These storms can cause significant damage to infrastructure, including electrical systems. Understanding the potential impact of hurricanes is crucial for preparedness and safety. Electrical work following a hurricane often involves assessing damage, repairing or replacing damaged components, and ensuring the safe restoration of power. This can include working on power lines, transformers, electrical panels, and wiring within buildings. Safety is paramount when working with electricity, especially in the aftermath of a disaster. Hazards such as downed power lines, flooded electrical equipment, and structural damage can pose serious risks. Qualified electricians must follow strict safety protocols and use appropriate personal protective equipment, or PPE, to minimize the risk of injury or electrocution. Common electrical repairs after a hurricane include replacing damaged wiring, repairing or replacing electrical panels, and ensuring proper grounding. Damaged wiring can create fire hazards and shock risks, so it is essential to identify and repair any compromised circuits. The electrical panels are the central distribution points for electricity in a building, and they can be damaged by water or impact. Proper grounding is essential for protecting people and equipment from electrical faults. Ensuring that electrical systems are properly grounded can help prevent electrocution and equipment damage. Power restoration is a critical task following a hurricane, and electricians play a vital role in bringing electricity back to affected areas. This often involves working with utility companies to restore power to the grid and then connecting individual buildings to the grid. The process of restoring power must be carefully managed to avoid overloading the system and causing further damage. There are several steps to take before, during, and after a hurricane to ensure electrical safety. Before a hurricane, it's advisable to turn off and unplug unnecessary electrical appliances to protect them from power surges. It is also important to know the location of the main electrical panel and how to turn off the power in case of an emergency. During a hurricane, stay away from downed power lines and flooded areas where electrical equipment may be submerged. Never attempt to repair or touch electrical equipment while standing in water. After a hurricane, have a qualified electrician inspect your electrical system before turning the power back on. This can help identify any hidden damage and prevent electrical hazards. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations and safety. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Electricians must be familiar with the NEC and follow its requirements to ensure safe and compliant installations. Some key NEC articles relevant to hurricane preparedness and recovery include Article 230. Covers service entrances, which are the connections between the utility power lines and the building's electrical system. Article 250. Covers grounding and bonding, which are essential for protecting people and equipment from electrical faults. Article 300. Covers wiring methods, which specify the types of wiring allowed in different locations. Article 408. Covers switchboards and panel boards, which are the central distribution points for electricity in a building. Article 445. Covers generators, which can provide backup power during outages. It's important to note that electrical codes and regulations may vary by location, so it's essential to consult with local authorities and qualified electricians to ensure compliance. The electrical grid is a complex network of power plants, transmission lines, and distribution lines that delivers electricity to homes and businesses. Hurricanes can cause widespread damage to the electrical grid, leading to power outages that can last for days or even weeks. Utility companies work to restore power as quickly and safely as possible, but the process can be challenging, especially in areas with significant damage. Smart grids are an emerging technology that can help improve the resilience of the electrical grid to hurricanes and other disasters. Smart grids use sensors, communication networks, and advanced control systems to monitor and manage the flow of electricity. This allows utilities to quickly identify and isolate damaged areas, reroute power around outages, and restore power more efficiently. Renewable energy sources, such as solar and wind power, can also play a role in enhancing the resilience of the electrical grid. Distributed generation, where electricity is generated at or near the point of use, can reduce the reliance on the central grid and provide backup power during outages. Microgrids are small-scale power grids that can operate independently of the main grid. Microgrids can be powered by renewable energy sources, generators, or a combination of both. They can provide reliable power to critical facilities, such as hospitals and emergency shelters, during hurricanes. Battery storage is another technology that can enhance the resilience of the electrical grid. Batteries can store electricity generated from renewable sources or the grid and then release it when needed. This can help smooth out the variability of renewable energy and provide backup power during outages. Electrical safety training is essential for anyone who works with electricity. Electricians must complete rigorous training programs to learn about electrical theory, wiring methods, safety practices, and code requirements. Continuing education is also important to stay up to date on the latest advancements in electrical technology and safety. The Occupational Safety and Health Administration, or OSHA, provides regulations and guidelines for workplace safety, including electrical safety. Employers must provide their employees with a safe working environment and ensure that they are properly trained in electrical safety practices. Personal protective equipment, or PPE, is essential for protecting electricians from electrical hazards. Common PPE includes insulated gloves, safety glasses, hard hats, and arc-rated clothing. Insulated gloves protect against electric shock, safety glasses protect against flying debris, hard hats protect against head injuries, and arc-rated clothing protects against burns from electrical arcs. Electrical testing equipment is used to verify the safety and performance of electrical systems. Common testing equipment includes multimeters, voltage testers, circuit tracers, and ground testers. Multimeters measure voltage, current, and resistance. Voltage testers detect the presence of voltage. Circuit tracers identify the path of electrical circuits. Ground testers measure the resistance of the grounding system. Electrical codes and standards are constantly evolving to reflect new technologies and safety practices. Electricians must stay informed about the latest changes to the NEC and other relevant codes and standards. Professional organizations such as the National Electrical Contractors Association, or NECA, and the International Brotherhood of Electrical Workers, or IABU, provide resources and training to help electricians stay up to date on the latest industry developments. Electrical inspections are conducted to ensure that electrical installations comply with codes and standards. Inspections are typically performed by local government agencies or third-party inspection companies. Passing an electrical inspection is required before a building can be occupied or have its power turned on. Common electrical code violations include improper wiring, inadequate grounding, and overloaded circuits. Improper wiring can create fire hazards and shock risks. Inadequate grounding can increase the risk of electrocution. Overloaded circuits can cause breakers to trip and potentially start fires. Electrical safety audits can help identify potential hazards and code violations in existing electrical systems. Audits are typically performed by qualified electrical inspectors or engineers. The audit report will outline any deficiencies and recommend corrective actions. Preventative maintenance is essential for ensuring the long-term reliability and safety of electrical systems. Preventative maintenance includes inspecting and testing electrical equipment, tightening connections, cleaning components, and replacing worn parts. A well-maintained electrical system is less likely to experience failures or cause safety hazards. Surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning strikes or power grid disturbances. SPD divert excess voltage away from sensitive electronics, preventing damage. Whole house surge protectors are installed at the main electrical panel to protect all of the circuits in a building. Point-of-use surge protectors are plugged into individual outlets to protect specific electronic devices. Ground fault circuit interrupters, or GFCIs, protect people from electric shock by monitoring the current flowing through a circuit. If a GFCI detects a leakage current, it will quickly trip the circuit, cutting off the power. GFCIs are required in wet locations, such as bathrooms, kitchens, and outdoor outlets. Arc fault circuit interrupters, or AFCIs, protect against fires caused by arcing faults in electrical wiring. AFCIs detect the unique characteristics of arcing faults and trip the circuit before a fire can start. AFCIs are required in bedrooms and other areas where arcing faults are more likely to occur. Lighting protection systems protect buildings from lightning strikes. These systems consist of lightning rods, conductors, and grounding electrodes. The lightning rods intercept lightning strikes and direct the current safely to the ground through the conductors and grounding electrodes. Proper installation and maintenance of a lighting protection system can significantly reduce the risk of lightning damage. Understanding basic electrical concepts is essential for anyone who works with electricity. Voltage is the electrical potential difference between 2 points. It is measured in volts. Current is the flow of electrical charge. It is measured in amps. Resistance is the opposition to the flow of electrical current. It is measured in ohms. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. Power is the rate at which electrical energy is transferred. It is measured in watts. Power equals voltage times current, or watts equals volts times amps. Single-phase power is commonly used in residential and light commercial applications. It consists of 2 conductors, a hot wire and a neutral wire, and operates at 120 volts or 240 volts. 3-phase power is commonly used in industrial and heavy commercial applications. It consists of 3 conductors, each carrying a sinusoidal voltage that is 120 degrees out of phase with the others. 3-phase power is more efficient than single-phase power for large loads. Transformers are used to step up or step down voltage levels. Step-up transformers increase the voltage, while step-down transformers decrease the voltage. Transformers are essential components of the electrical grid and are used to deliver power to homes and businesses at the appropriate voltage levels. Generators convert mechanical energy into electrical energy. Generators can be powered by various sources such as gasoline, diesel, natural gas, or renewable energy. Generators are used to provide backup power during outages or to generate electricity in remote locations. Motors convert electrical energy into mechanical energy. Motors are used to power a wide range of devices, from small appliances to large industrial equipment. There are many different types of motors, each designed for specific applications. Electrical troubleshooting involves identifying and resolving problems in electrical systems. Troubleshooting requires a systematic approach and a thorough understanding of electrical principles. Common troubleshooting techniques include visual inspection, voltage testing, and circuit tracing. Electrical repairs should only be performed by qualified electricians. Attempting to repair electrical equipment without proper training and experience can be dangerous and could result in electric shock, fire, or other hazards. If you have any doubts about your ability to safely repair an electrical problem, call a qualified electrician. Electricity is a powerful force that can be dangerous if not handled properly. Always follow safety precautions and consult with a qualified electrician when working with electricity.